So we're going to continue where we left off yesterday with rational expressions. And basically when we deal with rational expressions, we want to always find our NPVs so we don't have 0 on the bottom. We never want to divide by 0. Dividing by 0 is a problem. And then we want to simplify our expressions, and to simplify, we're going to be doing a lot of factoring. So if you weren't good at factoring before, you are going to definitely get good at factoring now. So just a little bit of a review from, I don't know when you learned how to multiply and divide numbers. So if I have like 2/3 and I want to multiply by 4, I don't know, tenths. When you want to multiply a fraction, you can multiply the tops and multiply the bottoms. So 2 times 4 along the top, 3 times 10 along the bottom. So 2 times 4 is 8, 3 times 10 is 30. And then when it comes time to looking at my final expression, I can just see what are both of the numbers divisible by. So 8 and 30 are both divisible by 2, so I'm going to divide top and bottom by 2. I get 4 over 15, and then nothing is divisible from there anymore, and then that would be my final answer. When I want to divide two fractions, so say I'm doing 2/3 divided by 4/10, we don't really divide fractions. We know how to multiply by the reciprocal. So we're going to multiply instead of divide, and we're going to reciprocal the second fraction. And then we're going to do our multiplication step, 2 times 10 along the top. So multiply tops, multiply bottoms. 2 times 10 is 20. 3 times 4 is 12. And then again, it is expected you simplify your fractions. So you try to think of the largest number that both 20 and 12 are divisible by. 20 is divisible by 4 and 12 is divisible by 4. So I divide top and bottom by the same number. 20 divided by 4 is 5. 12 divided by 4 is 3. So you do have to remember your dividing skills and your multiplying skills with fractions in order to be successful with the rational expressions. So with rational expressions, this is going to be kind of an extension of the simplifying. You're going to end up factor, everything that's involved. You're going to look for similar factors in each expression. Then you're going to either multiply or divide like it's shown up here. Again, do another simplification step. And then at the very end, make sure you state all your NPVs. So key ideas, factor everything. Look for common factors in each expression. This is literally a simplify step. So you factor, you simplify. When you're done simplifying, you look to multiply or divide to make a single expression. And again, you divide out common factors, which is again another simplify step. And then stating NPVs is super important, but you want to be able to state them from all the steps. You can notice here the 10 was on the denominator and then the 4 is on the denominator. So I sort of have 2 denominator steps, and they're coming from 2 different processes involved. So you have to do NPVs at anything that shows up on the denominator. Okay. These steps will be listed out for you, but we're going to kind of go through practicing these 5 steps in all of the questions. And hopefully you'll notice it's just pretty much exactly the same as what we did yesterday, but now we just have more factoring to do and more simplifying to do. Multiply or divide, state any necessary restrictions. So my first step is to factor, but in this case we have monomials. So my factoring step is sort of already done. Okay, there's monomials, I can't factor anything. Now we're going to go through a simplify step within each. So I'm going to say simplify within. So that means within each fraction, there's one fraction, there's another fraction, and there's another fraction. So within each fraction, you want to simplify. So let's look at this one. 5m, 3n, nothing in common. 10n squared, 7m to the fourth, nothing in common. 21. Now in this case, I have m squared and m cubed. So m. So this step will clean up. They all have at least 2m, so I'm going to cancel 2 of them out. In my ends, I have 3 along the top and 6 along the bottom. You'll notice that both of them have at least 3 ends, so I can simplify that. So I'm going to write what I have left over. Orange fraction, can't do anything with it. The yellow fraction, can't do anything with it. The red fraction, we simplified. There's no more m's on the top, no more n's on the top. I have a 2 on the bottom. I have a single m left over and 3 n's multiplied out, which would give me n cubed. So I'm done my simplifying within step. Now I'm going to do the multiply or the divide. So in this case, I'm going to multiply. So tops will multiply. 5m times 10n. And instead of writing little multiply symbols, I'm going to write little dots to indicate my multiply. So I'll multiply all of that into a single expression. 3n squared, 7m to the fourth, 2mn cubed. So there's my multiply step. Now we need to do a simplify step. Well, we're not really quite done the multiply, but we're going to do the multiply and the simplify. So number. I'm going to multiply all those numbers together. So 5 times 10 times 21 is 1,050 mn squared. 3 times 7 times 2 is 42. I have m. You look here, I have 4 of them and then 1 of them. So I have 5 m's being multiplied out. My 3, my 7, my 2 get multiplied. And then I have n squared and n cubed. So I have a total of n to the 5. Now I need to clean up among, simplify between, or now simplify within again. So 1,050, I'm going to see, is it divisible by 42? It's exactly divisible by 42. So I'm going to highlight this in yellow. This and this both divide by 42. So divide by 42, divide by 42. And I'm left with 25 on the numerator. I'm going to look at m and m to the 5. So m on the bottom, m on the top, 3 m's on the bottom. They both have at least 1 in common, so I cancel 1 out. And I'm left with 4 on the bottom. And then I have n squared n to the 5. I have n and n. I should do that in black. N and n. N. They all have at least 2 in common. So I'm left with n cubed on the bottom. And therefore, my simplified expression is 25 m to the fourth n to the cubed on the bottom. And now I need to state my NPVs. Anything that sits on the bottom. There's an n on the bottom, not allowed to equal 0. There's an m on the bottom, not allowed to equal 0. You can just take each variable and set it equal to 0. You're going to cube root, fourth root, square root both sides. Each variable cannot equal 0. So this would be my simplified expression stating my necessary restrictions. Okay, so then it's my NPVs from each step, and we're done all those steps. In the next example, we want to factor. Okay, so a squared minus a minus 12 two numbers that multiply to negative 12, add to negative 1. It's going to be negative 4, positive 3, negative 4, and positive 3. I'm going to do the swing method. It's quick. My a value is a 1, so there's nothing really to worry about. Divide by 1, divide by 1. I get x minus 4, x plus 3, so I'm still on the factoring step. Now I'm going to factor the next term, which is the bottom. This will be a difference of squares, a minus 3, a plus 3. I'm going to look at my next expression, which is the numerator of the second fraction. Two numbers that multiply to 3 and add to negative 4. So positive or negative 1 and negative 3, negative 1 and negative 3. We're going to notice my a is 1. I'm going to go ahead and do the swing method because it's going to be the easiest in this case. Minus 1, minus 3, my a is 1. So this will factor to x minus 1 and x minus 3. And my last term, a squared minus 4a. This is a binomial term, two pieces, but there's no difference of squares, but I notice there's a GCF. I'm going to factor out my GCF, a, and I'm left with a minus 4. So a squared divided by a is a, minus 4a divided by a is minus 4. My factoring step is now complete. Okay, I'm going to kind of pull it aside. There's my factoring step. So what I'm going to do is I'm going to rewrite my expression with everything factored. Oops, and then you'll notice I wrote an x here, but this should be an a. So let's just come back and put it in as an a. A minus 4, a plus 3. On the bottom, a minus 3, a plus 3. Just make sure you work in the variable that's given. You can see I've already made a careless error. A minus 1, a minus 3, and then a minus 4. And I'm just going to fix this careless error. So this is going to be a. Again, we want to be careful that we work in the variables that are given to us. Those are all going to be a's as well. A. So now we have to simplify within. So I'm just going to call it simplify. So plus 3, those are common factors, identical on top and bottom within that fraction. There's nothing in common here. So now I'm done my simplify step. Now I'm going to do my divide or my multiply step. In this case, it's my multiply. So I'm going to put the tops together. And then I'm going to put my bottoms together, the a minus 3, the a minus 4. So there's my multiply step. Now I'm going to do another simplify step. So look for common factors. A minus 3, a minus 3. Those will both cancel out. They're identical factors. So I'm left with a minus 4, a minus 1, a minus 4. You can notice, and I didn't notice it till just now, another a minus 4, a minus 4. I'm also going to go ahead and cancel those out in this step. So finally, I'm left with, let's erase all this. I'm left with an a minus 1 on top and an a on the bottom. Now, when I'm dealing with restrictions, anything that comes from the bottom, a cannot equal 3 because 3 minus 3 is 0. A cannot equal minus 3 because minus 3 plus 3 is 0. A cannot equal 0 because 0 times anything is 0. And A cannot equal 4 because 4 minus 4 is 0. I look on the bottom, there's nothing new other than those terms. So A cannot equal 3, minus 3, 0, and 4. And that would be my simplified expression for that division statement that was given on that expression. Okay. Next example is a multiply example again. Our goal is to factor. So let's write our steps down. Factor. Y squared minus 9 has 2 pieces in it. It can only be GCF factoring or difference of squares. This one is difference of squares. The square root of y squared is y. The square root of 9 is 3. And then I have my y plus 3. I have my r cubed minus r, which is 2 pieces. This one has a GCF of r. So I'm going to factor out the r. R times r squared is r cubed. R divided by r is 1. And now it's a difference of squares. So now I have to keep factoring until I'm completely done. Square root of r is r. Square root of 1 is 1. One bracket has a minus. One bracket has a plus. R squared minus r. Again, another GCF term. There's an r, so I factor out the r. I'm left with r minus 1. R squared divided by r is r. R divided by r is 1. And y plus 3, I can't do anything with it. It's a binomial, but there's nothing in common. And nothing else can factor out. Let's make this a bit smaller. So there's my factoring term. I'm gonna write this in factored form. Y minus 3, y plus 3, r minus 1, r plus 1, times r minus 1, y plus 3. You want to do your simplify step within. So within my fraction, there's nothing in common. Y minus 3, y plus 3. This fraction can't be simplified. That fraction can't be simplified. I'm going to do my multiply step, which means I'm going to combine everything into a single expression. Y minus 3, y plus 3, r minus 1, r minus 1, r plus 1, y plus 3. And now again, I'm going to do another simplify step. Let's highlight things that are in common. Whoops, that's not correct. Y plus 3 can cancel. R and an R minus 1 and an R minus 1 can cancel. Those are all identical on top and bottom. So I'm left with y plus 3, not plus 3, y minus 3, divided by r plus 1, and I'm ready to state my NPVs. So I can get 1 from here, 1 from here, 1 from here, 1 from here. Those are the same 4 terms that are on the bottom over here, 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 and here. So r cannot equal 0, r cannot equal 1, r cannot equal negative 1, and I have a y term. Y cannot equal negative 3. So I'm ready to state it. So r cannot equal 0 plus or minus 1, and y cannot equal minus 3. You can kind of circle that or square that in. That would be my final answer to the problem. So we're pretty much focusing on those 5 main steps. That's how multiplication works. With division, we get another NPV step in there, but we'll kind of go through that in the next example. So these ones look a bit complicated, but really it's not super complicated. My first step is to factor, so let's go ahead and factor. X squared minus 4, that's a difference of squares. The square root of x is x. The square root of 4 is 2, so I'm going to have a term with x plus 2, x minus 2, so I'm going to write that in. Divide by. I have my x squared minus 4x. This has two pieces, but not a difference of squares. There's a GCF in there. They both have an x in common. So we're going to factor out the x. X squared divided by x is x. Minus 4x divided by x is minus 4. You can also see that I'm going to factor / simplify in that first couple steps. There's nothing in this bracket that can simplify. There's no common terms on top and bottom. For my x squared plus x minus 6, this is my trinomial factoring. Two numbers that multiply to negative 6 and add to positive 1. So 3 and negative 2, 3 and negative 2. I'm going to do the swing method again. It's pretty quick once you need to work really quickly. My a value is 1, so I'm going to get a positive 3 and negative 2. Divide by my a value, which is 1. And then I'm ready to write my factored expression, x plus 3, x minus 2. And then my last factoring step for that last piece, x squared plus x minus 20. Two numbers that multiply to negative 20. The same two numbers have to add to 1. You carefully figure out your numbers. Negative 4, positive 5 will work for both. My a value is 1. I'm going to do my swing method. So minus 4 and positive 5. And then I want to divide both of these by my a value. In this case, it's just 1, but when it's not 1, you have to modify it. X minus 4, x plus 5. Now, what I'm going to do is I'm going to do my divide step, which is really a multiply step. I'm going to kind of write my NPVs as we're going along. This one, x cannot equal 0. This one, x cannot equal 4. This one, whoops, x cannot equal 4. So you wouldn't repeat yourself, you would just state it once, but I'm just going to write it again here. And the last one, x cannot equal minus 5. But now you're going to see something else happen when I do step 3, which is the divide step. So I'm going to do divide by multiplying by the reciprocal. So I get x minus 2, x plus 2, x minus 4 times, and now I'm going to switch my numerator and denominator of my second fraction, and I'm getting 2 more NPVs that are showing up. Because now I'm getting this term, which is x cannot equal negative 3. And I'm also getting this term, which is x cannot equal 2. So when I'm doing my simplify step, you're going to notice things cancel out. But when you're ready for the NPV step, which you can do at any time, embedded in there, I have 1, 2, 3, 4, 5, 6 NPVs in this case. So let's look what's in common. Within each bracket, nothing is in common. I'm ready to put them together. X minus 2, x plus 2, x minus 4, x plus 5, x minus 4, x plus 3, x minus 2. Highlight our identical terms. X minus 2 will cancel out. X minus 4 will cancel out, and then nothing else is in common. So I'm going to write what I have left over. X plus 2, x plus 5 over x x plus 3. X is not allowed to equal 0, 4, -5, -3, and +2. We can write them in any order as long as they're all there. So that means 5 NPVs. And that would be my simplified expression. So the trickiest part of this section is there's a lot of factoring to do. And with all this factoring that you do, you don't necessarily have the time to waste if you don't know how to simplify or to factor. You need to be able to factor very quickly. Now in this example, before I factor, I'm going to kind of do a step here. 2a squared minus 10a times, and I'm going to reciprocal this fraction, times 3 minus 2a. What I'm also going to do this time, which is a little bit different in the other example, is I'm going to highlight everything that ended up being on a bottom, and anything that's highlighted is where the NPVs would come from. So this one has no variable, so no NPVs. You're going to get NPVs from here and here, but again, you can't write them until they're in factored form. Now I'm ready. I'm going to factor everything, but I've just highlighted the NPV. So in this case, what I did was I did my NPV kind of a preview of it. I'm going to factor now. So there's 2a squared minus 7a minus 15. I need two numbers to multiply to -30, which is the -15 times the +2. And I need the same two numbers to add to -7. So you carefully think through that. 10 and 3 will work, so I need a -10 and a +3. And then you got to watch that my a value is a 2 this time. So I'm going to have my -10 and my +3 in a bracket with my x. And then my a value is divide by 2, divide by 2. So you want to simplify, and if the term doesn't simplify, you swing the number up. 10 divided by 2 is 5. 3 divided by 2 doesn't simplify, so you're going to swing the 2 up and get 2x plus 3. Okay, so that's my simplified expression for that first fraction, x minus 5, 2x plus 3. My next piece is 2a squared minus 10a, and you can see I've done it again. These need to be a's, not x's. At least I noticed it a lot quicker this time. So a. So be super careful that you don't make careless errors like I always tend to do. When I factor this one, there's a GCF. They both have a 2 in common and they both have an a in common. So I'm going to factor out the 2 and I'm going to factor out the a. What's left over? 2a squared divided by 2a is an a. 10a divided by 2a is a minus 5. So I'm going to get 2a minus 5. I'm going to re-highlight this expression because that's going to help me with my NPVs. There's going to be a 6 on the top. 3 minus 2a doesn't factor anymore. There's nothing in common. I can't do anything. So the only piece left I have to factor is the 4a squared minus 9. This one simplifies to a, well, the square root of that is a 2a. The square root of that is a 3. There's a minus in between, so it factors as a difference of squares. You get a 2a minus 3 and a 2a plus 3. I can put this as a fraction. There's an imaginary 1 on the bottom. Now you're going to notice, like we talked about yesterday, this is a 2a and this is a negative 2a. And this is a negative 3 and this is a positive 3. So what we can do is cross these brackets out and put a negative 1 with what we talked about yesterday. They're exactly the same, but they're off by a negative sign. So when they divide, it's like you dividing 5 divided by negative 5. Okay? Now, you're going to notice when I'm doing this third and fourth simplify step, I'm kind of doing the multiply and the simplify at the same time. Because I know I can just get rid of this and just put a big bracket over top. And then literally, there's my multiply step. And then I'm on my simplify step again. And then my NPVs just move to step 1, which we're still not done. A minus 5 cancels with A minus 5. 2A plus 3, 2A plus 3. I'm left with a negative 6 divided by 2A. And then you're also going to notice, well, oh, wait a minute. The 6 and the 2 are both divisible by 2. So I get a negative 3 divided by A. I'm ready to state my NPVs. Okay, so I'm getting 2A is not allowed to equal 0. Divide both sides by 2. A is not allowed to equal 0. A minus 5 is not allowed to equal 0, so A is not allowed to equal 5. 2A minus 3 is not allowed to equal 0. So 2A is not allowed to equal 3. A is not allowed to equal 3 over 2. 2A plus 3, so 2A plus 3 is not allowed to equal 0. So A is not allowed to equal negative 3 over 2. So I end up getting 4 NPVs, but if I'm not careful, I'm getting 2 from here, 2 from here. But if this had NPVs in it, the 6, then I would have missed some NPVs if I'm not careful. So this expression here would be my final answer with all my NPVs listed out. Now, hopefully you've had a chance to go through the practice sheet that was given out yesterday. I will post another practice sheet on D2L that relates to multiplying and dividing. This is just literally an extension of yesterday's lesson with more steps, okay? So there's an example for you to try here, which I'm not going to try. There's a division sign, so you're going to do the kiss and flip and go through all of that. And then we'll talk about this example tomorrow if there's any trouble with it.